Ladies and gentlemen, we are proud to introduce Quark II. Our mission is to reach 500 meters using a solid motor, with low cost and high safety. We use a three-bay design, an electronic bay for intelligence, a motor bay for power, and a recovery bay for safe landing. Based on the Quark II framework, our airframe uses a fiberglass layup, 3 layers of 200 GCM and 1 layer of 100 GCM, reaching the ideal thickness and strength for this profile. Sections are joined by aluminum couplers, validated through ANSYS and FLY, to withstand 100 times what they needed to do.
That's where aerodynamics comes in. The Quark II features an elliptical nose cone to minimize drag at its subsonic speeds, a conical boat tail, and trapezoidal fins with an ACTA 0011 profile, all 3D printed in ABS and bonded with epoxy to the structure. Stability was verified using OpenRocket, including crosswind simulations of up to 10 meters per second, showing a consistent static margin between 1.8 and 2.5 calibers. The rail exit speed is approximately 30 meters per second with a simulated apogee of 550 meters. With the aerodynamic envelope defined, we could size the motor to deliver exactly what that trajectory needs.
Our motor uses 3 KNSB grains with a paper as thermal protection, a nozzle throat of 10 mm and an expansion ratio of 6.5. Producing an average thrust of 347 newtons over 1.26 seconds, a total impulse of 479 newton-seconds and a peak pressure of 4 MPa. The motor is secured to the structure through 3 M3 bolts connecting the bulkhead to the lower coupler. This motor defines the entire flight timeline, and that timeline is exactly what our electronics must read and act.
Our avionics architecture consists of 5 subsystems built for maximum reliability. The S32S3 Super Mini serves as the main microcontroller, managing flight events in real time alongside a sensor suite for state estimation, a regulated power distribution unit capable of firing the recovery squib, and a LoRa telemetry module linked to our custom ground station. A fifth, fully independent altimeter with its own isolated power supply provides redundancy for recovery activation, ensuring the critical ejection event is never dependent on a single point of failure. Speaking of that event, everything in this rocket is built around making it perfect.
At Apogee, a custom pyrotechnic ejector, a black powder-driven pressurized cylinder, fires a piston to deploy the parachute precisely when needed. Ignition runs through a dual-channel system, primary and redundant, each wired independently to the 2 separate electronic systems. The black powder charge is sealed inside a custom-treated bolt, screwing directly into the piston for zero leakage before ignition. The semi-elliptical parachute, 110 cm in diameter with a 16% vent hole, delivers a stable oscillation-free descent at 7 meters per second, bringing Quark II home safely. Every system trusted the one before it. The structure held, the aerodynamics guided, the motor hired, the electronics watched, and the recovery body back. This is Quark III.